I'm Mr. Monty. Welcome back to Lesson 11 of our 2020 series. 20 lessons of 20 minutes a day for 20 days in preparation for the math placement exam at the community colleges here in Spokane. Lesson 11. We're stepping it up. We've been doing factoring for several lessons and tutorials now, but there's a whole series of expressions and equations and functions, real-world ones, that we can't factor because they're just not in simple form. They're complicated. Well, if we go back to our original standard form of a quadratic equation, ax squared plus bx plus c equals 0. This is important. It has to be equal to 0. So if it's not equal to 0 to start, we need to make it equal to 0. So you'll have to add stuff to either side so that we finally get it where it is set equal to 0. Once we have an expression in this form set equal to 0, then we can use the quadratic formula. Quadratic formula is here. Minus b plus or minus the square root of b squared minus 4ac all over 2a. There's several spots that can trip us up. So this lesson here, I'm just going to go through the flow one time, nice and smooth, and then we'll come back on different tutorials where we specifically focus on different parts. The first thing I want to do is remind us the objective. I can factor this equation, it's actually an equation now because it's set equal to 0, using the quadratic formula. What that gives us is the x values that make this expression 0. The reason we want to find those is it makes solving equations easier. It helps us in real-world context problems find out maxes and minimums so we can find answers to solutions. And if we wanted to have a graphical representation, we can see where it crosses the x-axis. We already know where it crosses the y-axis. When x is 0, y is 2. So when we're done with this today, we will have found the places it crosses the x-axis, the places it crosses the y-axis, and we'll have a pretty good representation because we know if this opens up or down. Let's get started. The first thing I need is to find what the values of a, b, and c are. A, b, c. Make sure that when you label these, you include the sign. One of the most common places to make mistakes in using the quadratic formula is in the pluses and minuses. So a equals 1, b equals positive 4, and c equals positive 2. Okay, now we know that x equals minus b plus or minus the square root of b squared. I always write it inside a quantity. B squared minus 4ac. 4 times a, which is 1, and c, which is 2. This entire thing is all over 2 times a, which is 1. Okay, so now we've substituted a, b, and c into the entire quadratic formula. Now we've got to do the math part. X equals minus 4, can't do anything with that yet, plus or minus 4 squared, that's 16. Now, when you see three numbers multiplied together, I go 2 times 1, that's 2, times 4, that's 8, minus, so be 4, 8, yep, minus 8, all over 2 times 1, which is 2. Okay. X equals minus 4 plus or minus 16 minus 8, square root of 8, all over 2. Now, at this point, let's say we don't have a calculator. Could we leave it this way? You need to check with either your professor or your teacher or the class that you're in and find out what they expect. What's the expectation to get a perfect score on your assignment or your exam? For this example, I want to go all the way down to the point where we can put it on a graph. So let's continue. X equals, I don't have a calculator either, so this might be a little difficult. There's a couple of steps at this point. The first thing we can do is, I'm going to, in a red pen here, I want to see what I can do with this right here. I know that that's the same as the square root of 4 and the square root of 2. Square root of 8 is equal to the square root of 4 times the square root of 2. Square root of 4 is 2. Square root 2. I don't know the square root of 4, or excuse me, I don't know the square root of 2. But I do know, what do you think of this? Let's erase that and say this. I know the square root of 9 is equal to 3. So this is going to be less than 3. Square root of 4 is 2. Well, this is 8, so that's going to be closer up here. So, because I don't have a calculator, I'm going to say about 2.8. Let's see how close we come. 2.8 all over 2. Okay? Whenever we take the square root, we have to use the plus or minus, because think of it like this. We could have 2 times 2 is equal to 4, or minus 2 minus 2 is equal to 4. So whenever we're taking the square root of a number, if you didn't know that or you forgot from an older math class, this is one of those things you need to remember when working with the square root sign, the radical sign. Anytime you take the square root, there's going to be 2 answers, a positive and a negative. Okay, so at this point, I'm going to break it up into 2 answers. x1, I'll call it, will be minus 4 plus 2.8 over 2. And x2 will be minus 4 minus 2.8 all over 2. Okay? Well, let's complete these. Minus 4 plus 2.8, that'll be 1.2 all over 2, which is 0.6. The bottom one down here be 6.8 minus 6.8. Thank you. Good catch. See how easy it is to make a mistake? Minus 4 plus 2.8. That should be a minus in there. Yeah. I made a mistake there. Good catch. Minus 6.8 all over 2, which is equal to minus 3.4. So now we've found the zeros. Using the quadratic formula, minus 0.6, so it'll be about right there. Minus 3.4, 1, 2, 3.4, about right there. Y-intercept, when x is 0, plus 2, 1, 2, and the x squared is a positive, so that means it's a smiley face. So it's going to be some sort of shape like that. We're not sure what the vertex is at this point without doing a little bit more math, but the quadratic formula helped us factor the expression. Let's write it in factored form, because our original objective was I can factor the equation using the quadratic formula. Okay, x plus 0.6 x plus 3.4 is the factored form of this expression. If we were to actually go back and check it, we would see that 0.6 times 3.4 is 2. So that's really cool. Now, if you're confused, how did I go from this step to this step? Watch this. All we're saying is when we factor an expression is can we make this expression 0? Well, if I take this and make it a 0, 0 times this would be 0. Or if I make this 0, 0 times this is 0. So what I'm doing is I'm setting x plus 0.6 equal to 0 and x plus 3.4 equal to 0. Subtract the 0.6 from both sides. X equals minus 0.6, which is what we had here. Or this one, subtract the 3.4 from both sides. X equals minus 3.4, which is what we had down here. So in some cases, I know students like to memorize, and they'll take this x1 and say, oh, I just make it the opposite. This is why you're making it the opposite. Because if I put a minus 0.6, minus 0.6 plus 0.6 is 0. Likewise, minus a 3.4 plus a 3.4. So when these are pluses, it's on this side of the y-axis. If this is the first time you've used the quadratic formula, it can be difficult and confusing. A lot of steps and a lot of math in several areas where the pluses and minuses can trip you up. This completes lesson 10. Actually, this was lesson 11. Thank you. So this completes lesson 11 in our 2020 series, using the quadratic formula in order to factor an expression. See you next time.